Welcome everybody to our show today, our second try at our show today. We had some minor technical difficulties. If I can't speak, we'll have another technical difficulty yesterday, but hopefully all that is ironed out and we will get to rock and roll today. So today we're doing our presentation from I&E of an introduction to networking technology. So let me just go through a brief introduction of what our show is about today, who I am, and then we can get right into it. So let me sort of paint a picture for you as far as who I'm envisioning the learner is that this show was designed for. So this is designed for somebody who knows absolutely nothing about networking technology. In other words, as far as computers is concerned, you're one of those millions or billions of people who has a computer, or maybe you have a tablet and you know how to turn it on. You know how to bring up your web browser so you can view Google or your email or something like that. But as far as actually how all that stuff works in the background, how you're actually getting on the network, what a network is, you have no clue. And you're kind of interested in that. You're kind of curious about, okay, what is this thing called a computer network? What are the basic nuts and bolts of it? And what job opportunities exist in this world of computer networking? Is this something I might want to look at as a future career or maybe an enhancement to my existing career? So that's who this show is geared towards. So if you are currently studying for an entry-level certification like Cisco CCNA, this will still be of benefit, of use to you. But if you're beyond the CCNA, if you're pursuing something higher than that, like a CCNP or above, this stuff will probably be way too basic for you. So that is who this show is geared for. That's why I've called it an introduction to networking technologies. And the way I've put this together is in bite-sized segments. So I'll be talking for about 10, 15, maybe 20 minutes, and then I'll have a break for Q&A. And at that point in time, I'll look at the questions that you're posting here via YouTube, and I'll do my best to answer the questions that you have. Now, there's a lot of people watching via YouTube, and there's a lot of people with a lot of good experience and knowledge. So feel free to type in your question into the YouTube chat stream at any time you want. Even though it's not necessarily my official Q&A time, if you type in your question, somebody will probably be able to answer it for you. And then during the Q&A time, I'll scroll back and forth, and anything that I see that was unanswered, I'll go ahead and take a crack at that myself. So with that being the case, in the event that you've never seen a show from me before, let me just briefly introduce myself to you. So my name is Keith Bogart. I'm one of the staff instructors and course developers here at I&E. My particular specialty is delivering content and creating content related to the CCNA and CCNP specialties for routing and switching here at I&E. So that's what I do. If you have questions during today's show that don't get answered, and that's a distinct possibility because there's a lot of stuff that gets posted on here. Number one, I would actually prefer that once the show is done, if you still have an unanswered question, that you post your question on I&E's online community. And that way, other people can benefit by seeing your question and seeing the answers that were posted to that question. So it benefits not only you, but other people. Now you might be saying, Keith, what is the I&E online community? Well, let me show that to you and show you how to get on there. No credit card required or anything like that. So from here, just go to ine.com. And you can see right now we've got a pot of rack tokens going on. So you get a lot of rack rental tokens that will allow you to practice a lot of networking technology on the various racks that we have. So that is our current special in promotion. You might want to check that out. But from here, if you scroll down to the very bottom, all the way down, you will see right here in the lower left-hand corner where it says IEOC Forums. So right there. So you can click on that. Now, if you don't already have a registered username and password for I&E, at this point, you'll have to sign up for one. Like I said, all you need is to provide your name and a username and password and your email address. and that will get you into our community as well as a bunch of other places as well. So from here, you would go ahead and any questions that you have regarding today's show, these basics of introduction to networking, you would want to scroll down and click on Cisco CCNA. Okay? And then from here, you'd probably want to post your questions under CCNA because that has the most viewers and the most questions. And from here, once you're logged in, you can just start a new discussion and that will get you going. Now, in the event that you post a question here and 24, 48 hours goes by and nobody responds back, which is highly unlikely, then by all means, reach out to me directly. And you can see here my contact information. There's my email address. There is my Twitter account. There's my LinkedIn information. Oh, let me add my social security number and blood type to that. Actually, not going to give that to you. But that's ways that you can reach out to me if the INE online community doesn't give you an answer to your question. So with that, let me talk once again just about the course objectives. This is just a rehash of what I already covered. For those of you thinking of pursuing a career in computer networking but are still investigating, this course will identify what a computer network is, the components of a network, and potential job roles. So here are the topics I'm going to cover, and after each one of these sections, I'll take a break and go through whatever questions you've posted via YouTube. Now, are there any prerequisites for this? No. Pretty much you've got it. If you're watching me right now, that means you've met the prerequisites, so don't have to worry about that. We've already talked about the Q&A time, so we'll get to that. I've already given you my contact information, so we are good to go. So let's start with section number 1 here. What is a computer network? And I'm going to cover 3 sort of high-level concepts. The parts of a common computer network, some vocabulary, some terms that you need to know, and why do we need computer networks? So let's start out with what is a computer network? Technically speaking, a lot of times when people think of computer networks, they think of these big, massive, complex things that have got all sorts of moving parts. And yeah, a computer network could be like that, but doesn't have to be as complicated as that. So a computer network technically is anything that allows 2 computing devices to share information. So it could be as simple as I have one laptop, another laptop, I connect a cable between them, and voila, I have just created a computer network. Real simple computer network, but that fits the classification of a computer network. So, but let's take it a little bit larger than that. So back in the old days, so we're talking about the late 1970s here, back before probably many of you were even born, a computer network looked like this. So you had several people and they were all connected to, back in the old days, this is even before PCs and laptops even existed. This is back when big mainframe computers existed. And if you don't know what a mainframe computer is, that was a computer that was like the size of your bedroom. It was massively large and it couldn't even do 1,000th of what your laptop can do today. So back then it was really big, really powerful, but now not so much. But you had these computing devices and you wanted them to be able to exchange information. So they created a cable. All these devices would tap into the cable. So in this case, we've got a bunch of laptops and PCs all tapped into this cable right here. And so we've got one computer network here, and we have another computer network right here. 2 different departments, right? Maybe department A is payroll, and department B is human resources. So we want them to share information. In order to do that, we have to connect them up to each their own separate computer network. And I'll talk in more detail about, well, what are the components that actually make this work? Now, in this particular environment, because they were all connected to the same cable, when you connect to a computer network, there are rules called protocols that you have to follow. And depending on what protocol your computer is using will dictate what the rules are. For example, Some protocols say, okay, when I connect to a network, I can just talk whenever I want. My laptop, my computer can just start putting out information on the wire whenever it wants to, doesn't have to wait. Some protocols say that. In this type of protocol, in the early networks, it wasn't like that. In the early networks, because everybody was tapped into one physical strand of wire, one cable, the protocol that ran on that network said, okay, if you want to talk, you have to listen first. Listen and make sure that nobody else is talking. You have to be polite, make sure that everybody else is quiet. And if everybody else is quiet, then you can talk. The rules, the protocol enforced also a certain amount of time you could talk. It said, look, you can't just talk forever and force everybody else off the wire. You can only put your information on the wire for a certain amount of time, and then you have to stop. Give somebody else a chance. So, if we only had like this, like 3 or 4 people on a wire, that type of protocol worked just great, right? But once you start getting more and more people added to that wire, once we start having 20 devices and 50 devices and 100 devices, now we start running into some problems. That particular protocol wouldn't work so well because my computer, every time it wanted to talk, it would have to listen first and, oh, the wire's busy, somebody's talking. Okay, I gotta wait. Oh, the wire's busy, someone's talking. I gotta wait. So you can see, with the more devices on the wire, using these rules about you have to wait till the wire's free, those periods of being free would be less and less frequent and be much more difficult to get on the wire and to talk. So we'll talk about what was invented to sort of get around that problem. So here we have 2 separate networks. They can't talk to each other. Department A can exchange data amongst themselves, but they can't get to Department B, and vice versa. So then some people said, well, we want these 2 networks to be able to communicate. But here's the thing. When you put information on a wire, when you're putting information on a network, the information you're putting on the network can actually go one of 3 places. There's one of 3 destinations. So for example, one type of destination is what's called unicast. And this is a term you need to know. Unicast, which means one-to-one transmission. So for example, if Bob here is putting information on the wire that's only meant for Sally, that is called a unicast transmission. Okay? And so now if this wire is shared, which it is, if everybody's on this wire, that means by its very nature, when Bob starts talking, everybody else on the wire can hear it. It's kind of like when you're in a room, right? Everybody can be quiet. When you start talking, maybe you're talking to Sally who's standing right next to you, but everybody else can hear you talk. So in that environment, what do you need to do? First, you need to preface your conversation with, Sally, you need to say who you're talking to, right? So that Sally knows, oh, Keith's about to talk to me. So in this type of protocol right here, in a unicast transmission, because everybody could hear everything, you had to preface, you had to start your transmission by saying, hey, Sally, this information's for you. So that was called unicast. Forgive my bad scribbling right there. All right? The opposite of this was, once again, you're in a room and you want to say, hey, everybody, the room's on fire. That's called a broadcast. A broadcast is when you're sending something to everybody on the network. So like in that case, I had to start out by saying, hey, everybody, right? So in networking terms, when you're putting your data on the wire, the beginning of that data has to have something that says, hey, everybody. So everybody on the wire knows it's for them. That's called a broadcast. And then there's a third type that gets really sort of complex, which is called a multicast. A multicast is where you put something on the wire and it's not meant for one person, it's meant for a group of people, but not everybody. So for example, Tom here is putting something in the wire and both Sally and Bob want to pick it up. They want to see it, but Sue over here is not interested in it. That's called a multicast. In other words, it's not one-to-one, it's not one to everyone, it's called one to many, and that's called multicast. Okay? So, once again, we're back to the situation where we say, okay, well, I want Department A and Department B to be able to communicate. I want unicast messages to go back and forth. In other words, I want Tom here to be able to talk to Paula over here, who's in a different department. But right now they can't, because their networks are physically separate. There's nothing connecting them. So I need to put some sort of device right here that's going to connect those networks together. And that device, as we put it in right here, so there we go. There was a couple of options here as far as what that device could be. If that device was something called a hub, that was a very early networking device. Basically what a hub did is it's like it connected these two cables together. It took two physically separate networks and joined them into one. So now everything that Department A put on the wire was seen by Department B. And everything Department B put on the wire was seen by Department A. So on the one hand, now the people can talk to each other, but on the other hand, we no longer have our privacy, right? There was a reason why we started out with two completely separate networks. We wanted to keep Department A and Department B separate from each other. We didn't want them to see everything. Well, then in that case, a hub would not be a good solution. Then in the evolution of things came bridges, and then nowadays we have devices called switches. So bridges and switches are a little bit more intelligent than hubs in that if Tom here is sending something to Sally, all right, let's say that's Tom right there and this is Sally right here. Well, if that device right there was a hub, not only would everybody on the top wire see that information exchange, everybody on the bottom wire would also see the information exchange. But if we have a bridge or a switch here, the bridge or switch is smart enough to know, oh, this conversation between Tom and Sally, which came in on, some port right here, some interface, doesn't need to be seen by these people. They don't need to see it. So without going into any more detail than that, the main takeaway I want you to have from this is that networks evolved from everybody connected onto one physical wire to now each PC had its own unique cable, and that unique cable was connected to the central device, which I'll just call a switch. Well, it's called a switch right now. And that's the way most networks are today. Most wired networks, the cable that's coming out of your computer or coming out of your laptop is not physically connected to other computers and other laptops. That cable is going to one place, it's going to a switch. And then other laptops, other PCs have their own cables going to a switch as well. And that switch is what's providing the connection or the communication path between each of those devices. Okay, so this allowed Department A and Department B to communicate. And then later on, the evolution of networks continued and people started saying, well, this is great for back in the day when you would come in, you would sit down in your cube or in your office, and you'd have a big personal computer, a big PC that never moved, like a tower computer that sat on your desk or underneath your desk, and you had your monitor there, and it was just part of the furniture. It was part of your desk. It never moved. But as devices evolved, laptops came out, right? And what was one of the big benefits of having a laptop? A laptop benefit was you could pick it up and you could move it to another room or another office. It wasn't constrained to just sitting in your cube. And the people start saying, well, man, the downside with networks as they are today is if I want to take my laptop out of my cube and move it down the hall or to a training room in the next building over, I have to unplug my cable, carry my laptop with me, and while I'm carrying it, I have no network connectivity. I've lost my ability to send emails. I've lost my ability to check the internet until I move to the next room, set my laptop down, plug in a cable again, and now I have network connectivity. And people said, hey, a laptop is a mobile device. It can move around, right? And then tablets and smartphones came out, which could also move around. And people said, wouldn't it be nice if my tablet was always connected to the network, even when I'm moving, even when I'm carrying it down the hallway or in the elevator or something? Well, certainly you can't be connected to a wire if you're doing that. Hence, wireless networking came into play. What we now know as Wi-Fi. And so that's what we have right here. So in this scenario, each laptop or PC has a special component. You can actually see it with your eyeballs that you plug your cable into. And we'll talk about that. That's called a network interface card. I'll get into that. in this scenario right here, your laptop or PC still has something that connects to a wireless network, but you can't see it. Visually, you can't really see it. But that thing that connects you to the network doesn't connect to a cable. It actually has a little radio inside of it. So nowadays, pretty much all tablets, all smartphones, all laptops have a tiny little miniature radio inside of it, which gives you wireless connectivity to a Wi-Fi network. Now, clearly, we probably still want our Wi-Fi users to be able to talk to and send information to our wired users. So then we have to connect our wireless network to our wired network. And we'll talk about what these various components are here as we go along. Now, let's move on here. So back in these days, so imagine right now we're like 30 years ago, okay? And imagine you've got a tall building that's like 10 floors, like a skyscraper that's 10 floors tall. And each floor has maybe 5 or 6 different departments on it: payroll, human resources, marketing. Well, each one of those departments most likely had their own servers. Now, what do I mean by servers? Well, like payroll, they would have a special computer set aside just for them that would be for their own payroll information, their payroll documents, their payroll spreadsheets, their payroll, salary information. It'd be a payroll server. That's where they would store their information. Marketing would have their own server, their own special computer that had information just for them, the graphics and images they use for their various documents, the marketing brochures, virtual, electronic brochures they had come up with, information about the latest sales events coming up, right? So every department would have their own server with their own specialized information on it. Well, the problem with that was if someone from payroll called up the IT staff and they said, hey, we can't get to our server. We no longer have access to our payroll information. I want to give Bob a raise, but I can't go in there and change that. The payroll server is unreachable. Well, now the IT person would have to say, oh, okay, do you know where your server is? No, I'm just a payroll guy. I have no idea even what a server is. So now the IT guy would have to say, okay, let's see, let me look up my paper right here. Okay, payroll, you're on floor number 6. And according to my picture here of what the floor looks like, according to this, your server is in cube A123, which is in the lower left-hand corner. So then the IT staff would have to get up, walk over to that server and troubleshoot it, figure out what was going on. And so then the idea came up with, wouldn't it be nicer if, number one, if all these servers were located in one central part of the building? Number one, it would make troubleshooting a lot easier. We wouldn't have to track down, where's the marketing server? Where's the payroll server? Where's the HR server? We would know. They're all in this one room right here. Number two, it'd make it a lot more secure. If we could take all those specialized servers that each department's using and put it in a locked room that has badge access that only certain people can get into, now we don't have to worry about someone messing around with that server that's not supposed to be on it. So then networks evolved, and that special room is called a data center. So if you ever hear that term data center, all that means is it's a special room with a lot of electrical circuits in it, a lot of air conditioning in it, that's got just tons and tons and tons of servers. So servers from all the company are co-located or located in this one central area called a data center. And clearly, we would need to connect that data center to our network as well, so we could get to and from those servers and push information to them and pull information from them. And then lastly, this network as it is, as I've drawn right here, is great if all we want is to exchange information within our company. But everybody wants access to the internet these days, right? This company is probably going to want to have a web server. They're probably going to want their employees to be able to get out to the internet so they can, use Gmail or something like that. So our last component of our sort of basic network is our internet connection to our internet service provider. The internet service provider, in case you're not familiar with that term, is, that's Time Warner Cable, that's Spectrum, that's Comcast. That's the company that you're paying a monthly bill to give you access to the internet. So we call that an ISP, or an internet service provider. Okay? So that is sort of how networks evolved over time and sort of the common components of your typical business network today. Now let's look at some common terms as well, some vocabulary that you need to be familiar with. LANs versus WANs. So clearly those are acronyms. So a LAN stands for a local area network. What defines a local area network? Well, number one, geography. In other words, a local area network is confined to a specific scope or range. A LAN can be as small as 2 computers connected via cable. That's a LAN. The largest size that a local area network can be is typically maybe like a few blocks from end to end. For example, Cisco Systems has several campuses throughout the world. And one of their campuses here in North Carolina has about 15 buildings in it. It's a pretty large campus. Thousands of employees working in that campus. And that campus is spread over several acres of land. So from building 1 over to building 15, it's probably maybe a quarter of a mile, maybe an eighth of a mile from one end to the other. Now, in that campus of all those acres, Cisco controls the entire network. All the cabling has been laid down by them, has been buried in the earth from one building to the other by them. So that is considered a local area network. That entire network is owned by Cisco. They control it. They purchased all the equipment. They manage all the equipment. And it's contained in geography. It's not hundreds of miles from one device to the other. It's about an eighth of a mile or maybe a quarter of a mile between the farthest devices on that particular network. So that's called a local area network. So one of the main sort of criteria of a local area network is everything in it is owned and controlled by you. It's owned and controlled by the IT department or the networking staff, from the cables and everything connected to those cables. So you control it all, as opposed to a wide area network. So if I have my Cisco office in Raleigh, North Carolina, and they want information from their network to go to the Cisco office in San Jose, California, well, Cisco does not have a cable that's buried underneath the earth that's 3,000 miles long that goes from North Carolina to San Jose. They don't have that. Now, Cisco probably does have the money that they could do that if they wanted to, right? Cisco has billions and billions of dollars, so theoretically, they could technically dig a trench 3,000 miles long across the United States and bury a cable. But they would never get the governmental permissions to do that. It would just be too difficult to do that. They wouldn't be able to do it. So what Cisco has to do is they say, well, there are internet service providers out there like Spectrum, Time Warner Cable, and they already have all of what we call the infrastructure. The infrastructure is all the cables and all the devices that make up your network. So whether your network is really tiny, just like 3 pieces, or really large, everything that makes up the network is what's called the network infrastructure, okay? So Cisco says, we need to find a network infrastructure that will connect our office in North Carolina to our office in San Jose. We don't own the infrastructure. It's not part of our LAN, so we will go out to Time Warner Cable, Spectrum, AT&T, and we will use their infrastructure because they do have cable stretching across the oceans and across the continents. So we are renting their network, and that is called a wide area network. So wide area network is something that, number one, connects devices that are very far apart in geography, and number two, you don't own it. You get to rent it, right? You get to rent time on the wide area network by purchasing services from your internet service provider. So that's a LAN versus a WAN. Another term is a node or host. So node or host are basically 2 words that mean pretty much the same thing. It's any device that, let me draw something like this. So here is a PC. Here is another PC. Here's a switch. Here's a switch, which is a networking device. And here's another type of a networking device called a router. Okay, so PC-A and PC-B are connected via these devices right here. Okay, every single thing here, so all 5 devices that I've drawn, the 2 PCs and then the 2 switches and the routers, are considered nodes. So we could say so basically anything attached to a cable is a node. Now, host is a term that's typically used for something that is generating data, generating information. In other words, we don't normally think of the switch or the router as generating information or starting information. We think of the PC as start. So this is the point where the information starts, and then it just goes through the network and then terminates right here. So wherever the information starts and terminates, those devices are typically what we call hosts. So think of your tablet, your smartphone, your laptop, your servers. Those are hosts. They're also nodes, but host is a little bit more specific. A host is really something that's starting or terminating the data exchange. The routers and switches, the networking components are just facilitating that. They're just passing the information on through. Another term, local versus remote resources. So a local resource is something that you can use on your laptop even if you have no networking connectivity at all. For example, you bring up Microsoft Word, Microsoft Excel, right? You can use those on your laptop and you don't have to be connected to the network at all. That's a local resource. Your hard disk drive in your laptop where you store everything, that's a local resource. Your monitor, your DVD-ROM drive in your laptop, that is a local resource. But anything that you're not physically connected to that you need the network to reach, that's called a remote resource. So for example, when you go to google.com, well, that website is not on your laptop. If you had no networking connectivity, you couldn't get to google.com. So that website is on some computer somewhere that's not you. So that computer that's hosting google.com is considered a remote resource. And then lastly, there's the internet. Now, most of you watching probably know what the internet is, but just in case, I want to cover my bases here. So the internet is really just a collection of billions of networks, billions of LANs that are all interconnected. So for example, when you have a network at your house, okay, so your network at your house is very small. It probably consists of your laptop, which is connected to a cable modem or a DSL modem, and then that is connected to your service provider. The moment you connect to the service provider and you are now able to bring up ine.com or google.com, guess what? You are part of the internet. Your small little network right there is now part of the billions of networks that are all interconnected together, and that huge collection of networks is what we call the internet. So when you're getting on the internet, basically you're just getting access to all these other LANs that various companies have out there throughout the world. So why do we need computer networks? Well, there's a couple of primary reasons. Number one, they allow us to share things. And there's three things that we can share: files, programs, and resources. So files. Think of, for those of you who may have used the website Dropbox, right? When you go on to Dropbox, number one, you're accessing a remote resource. When you go to Dropbox.com, your computer is now connecting to another computer, a much more powerful computer called a server, that is hosting the Dropbox website. Now, when you go into Dropbox, you will create like a folder, maybe a folder called My Personal Photos or My Videos or My Documents or something. So that is a file. It's not a local resource, it's a remote resource. And the network gives you the ability to create that file, and the network gives other people the ability to access that file. So now you can share that with other people. So that's what we mean by sharing files. Or maybe you create a file on your own laptop, and there's things you can do in that file that you can make it shareable so people in other networks can get to your laptop and get to that file that's right there on your own hard disk drive. Networks facilitate that as well. They allow us to share programs. For example, there are, let's see here, share programs. Well, you know, whenever you download a program, right? So if you're familiar with, if you have a tablet, chances are you have downloaded apps or games on your tablet. Well, what are you doing? You're downloading programs. That's what an app or game is. It's a program. And if you didn't have a network, you couldn't download that. You couldn't share that app or program. You couldn't get it from that server. And of course, they allow us to share resources as well. What do I mean by resources? Well, if you work in a company, chances are you probably don't have your own personal printer. You know, back in the old days, people in every single cube would have their own personal printer. Well, that got kind of expensive. Nowadays, a single office will have 1 or 2 printers that you can get to via the network. That's called a shared resource. It's a network device that you can reach via the network. Scanners that you can reach over the network, fax machines, all sorts of resources that you can get that you wouldn't have access to if you didn't have a network. So that's my basic intro there, and with that, let's go ahead and go to the YouTube session here and see if there are any unanswered questions that I can help you with. All right, so I'm just going to take a moment here to scroll up to the top. I don't see a lot of questions. Okay, well, I only see one unanswered question, and Salim, thank you. I appreciate the compliment. And hello back from Kathmandu. Wow, you're really far away. So Tech Lovers posted a question called, please describe about the MIMO feature. So that is definitely very complex. So I'm just going to do like a 50,000 foot view on what MIMO means. So basically the real high level idea of MIMO is this. First of all, MIMO stands for multiple input and multiple output. This is output. Okay. So this is a Wi-Fi technology, a wireless networking technology. And here's the basic idea behind it. Back when Wi-Fi first came out, you had a device like a laptop that would have a little radio inside of it, and you might even have had an antenna that's sticking out that you could actually see. Back in the old days, the old original Wi-Fi networking interface cards actually had a little antenna that you could see sticking out. And that connected via radio waves to another Wi-Fi device, which was called an access point. Okay, so here's my laptop with my Wi-Fi NIC card. Here's an access point, and your old access points would have maybe one antenna on them. Okay, so the idea behind multiple input, multiple output, once again, this is a real big overview, is that if we give more antennas to our devices, then they can send more streams of information at the same time. Instead of sending just one stream of Wi-Fi information out one antenna, I can get more information sent out by having more antennas. That's why they say multiple input, multiple output. So that's all I'm going to go into for here. It's much, much more complicated than that, but it's a Wi-Fi technology and it involves multiple antennas. So that's all I'm going to get into right there. All right. Are there any other questions I can answer before we go on to our next section? All right, so in our next section here, I'm going to talk about just some of the components of computer networks, and some of this stuff is going to be a rehash of what we already talked about. Some of it will be new. So I've talked a little bit about this concept of servers and clients. So today, in today's world, most of what you do on your laptop or on your tablet does not involve using your local resources. Yeah, sure, people still bring up Microsoft Word, Microsoft Excel, but if you think about it, most of what you do on your laptop requires that you have a connection to a network. If you didn't have a connection to a network, probably 80% of the things you do in your daily life, you would no longer be able to do. So in most networks today, you have this idea of a client-server architecture. What does that mean? Well, let's say that my laptop and your laptop are connected to the same network. All right, let's say we're all both on the same cable. All right, and on my laptop, I have something you need. Maybe I have a file that has a bunch of photos in it. You know, photos from various pictures I've taken around the world, vacations, you know, whatever. And you need to get to that. Okay, well, if it's just you getting to my laptop, no problem. Connect the network, go into my file here that's got my pictures in it, and sort of change the permissions so that you can reach it, so you can access it. Now, a second person, and a third person, and a fourth person start joining this network, and they want to access the same folder that I've got with all these photos in it. Eventually, as more and more people get on the network wanting to access my folder with my pictures in it, we're going to start having a problem. Because as all these requests are coming in off the network, going to my laptop saying, Keith, can I get your pictures? Can I get your pictures? As those requests are coming in, my laptop has to have memory. So as the requests come in, you know, the request from Sally, I'll put that in memory for a second until I have a chance to get to it. As a request from Bob comes in, I'll put that into memory, because right now I'm servicing your request. These other requests are coming in a split second later. I can't service them all at exactly the same time. So as more and more requests come in, I need to have more and more and more memory in my laptop to be able to store all these requests until I have a chance to get to them. Secondly, the brain of my laptop, the processor of my laptop has to start running harder and harder and harder, because as the requests are coming in, I have to be able to, you know, if my laptop has a really sort of slow brain, a slow CPU, it'd be sort of like, oh, Sally, good to hear from you. Let me give you my pictures. Goodbye. Oh, Bob, good to hear from you. You know, that wouldn't work too well, right? Everybody would be like, hey, it's taking me forever to get these stupid pictures that I want. So I need a CPU that's fast and powerful, so I can say, here you go, here you go, here you go, here you go, and I can get in that memory and get that information out to you. Well, laptops weren't designed to be optimized for that kind of thing. You know, they only have so much memory, so much processor brain power, that they weren't designed to handle thousands of incoming requests for websites and files and programs. Hence, we created what's called servers. So a server is a computer. It just has a lot more memory than your laptop has, and the processor is a lot faster, a lot bigger and smarter than the processor on your laptop. So it's able to handle all these multiple incoming requests. If you think about Google.com, right? When you bring up Google.com website, what are you doing? You are sending a request across the network, a special electronic message, to a computer somewhere and saying, hey computer, I know you're hosting the website called Google.com. Can you show me that website? How many of those requests do you think come in every second for Google? Tons. I can't even put a number on it, but it's probably millions of requests every single second come into Google. There's no way a simple home laptop or home PC could handle that. So Google has probably multiple hundreds of servers with massive amounts of memory and CPU that can handle all those incoming simultaneous requests. So when we say that today's networks are really built on client-server architecture, what that means is that when you're in your typical office environment, chances are you're not sharing information with the laptop in the cube next to you or the laptop across the way. Even though you're all connected to the network, yours and Sally's laptops probably don't ever even talk to each other. What are you talking to? You're talking to the server that's in your office, or you're talking to the server that's in, Florida somewhere or in Russia somewhere. So a client-to-client network would be like where, hey, I'm exchanging information directly with Sally's laptop, directly with Tom's laptop. And that type of thing does exist, but that's not the majority of what's going on in networks today. In most networks today, stuff that leaves the client is going to a server somewhere. Okay. So here we have some pictures of clients. I've been mentioning laptops. Certainly a smartphone is a client. A tablet is an example of a client, right? And the server, we've already talked about that. Server is just another name for a computer, but it has a lot more memory, a lot more processing power than a client does. And we've already covered all of this. In the previous section, I called network resources by another name. I called them remote resources. Basically, two names for the exact same thing. Remote resource, network resource. It's basically the same thing here. So don't really need to cover this in any detail. All right, so I mentioned this, but I want to go into this a little bit more detail. So we talked about how a network is some kind of path that's used to transfer information from one computer to another computer. Now, that path could be a physical cable connecting the computers together. We talked about Wi-Fi networks where the path could be a wireless connection going through the air, right? Transmitting radio waves. As far as a cable is concerned, the information going across that cable could take one of two forms. It could be electrical energy, in which case the cable is a copper cable. It's a metal cable that's transmitting energy, electrical energy across it. Or we could use light. We could use like laser light pulses to go across the cable, in which case that cable would be composed of like glass or plastic or something like that. So regardless of what the medium is, whether it's a cable or whether it's the air, we have to have some component in our devices. Let's just start with server, with a laptop, that connects to that thing. So the component in your laptop or PC that connects you to that cable, that connects you to the airwaves, is called a network interface card, or a NIC. All right, so that's a term you'll definitely be hearing a lot if you pursue the networking industry as a NIC. So you got to have a NIC. And we can see here that there are several examples of NICs. So what you're seeing in this slide are NIC cards that connect to a cable. So I'll just say cabled NICs. And the cable is a copper cable. So the cable is being used to transmit electrical energy. Furthermore, remember how I said earlier, I said when you connect to a networking cable, or when you connect to some sort of medium, whether it be a networking cable or the wireless energy, there has to be some rule, some protocol in place that answers questions like, okay, how do I know when I can go? If something's coming in, how do I know if it's for me? When I send something, how do I address it so that Sally knows it's for her and the other people will ignore it? So there's rules or protocols that answer questions like that. These type of NICs that you're seeing right here fall under a certain set of rules called Ethernet. So today, Ethernet is the primary networking technology that connects you to your cable. So I just want, as a takeaway from this, I want you to understand that just like when you walk into a room with a bunch of people, right? You have to know the rules about how do I communicate in this room? What's the protocol, right? Depending on the nationality of the people and where they come from, the rules might be, oh, you must remain silent until everybody is quiet and looking at you, and now you can talk. And you can only talk for 10 seconds, then you must be quiet and give somebody else the chance to talk. That might be one set of rules. Or if you go into a room with a different set of people, the rules might be, hey, you just shout. Everybody's talking, and whoever talks the loudest, that's the person who gets heard. You can talk whenever you want, you just got to shout louder than everybody else. And you got to talk to everybody. Hey, everybody, this is for you. That's a different set of rules, right? So Ethernet is simply a set of rules for networking that answers those types of questions and is probably one of the most common sets of rules. So your laptop has a network interface card. Most of it you can't see. Let me expand this a little bit here. So what you see right here is only the connector that connects to the cable. If we're actually able to open up this laptop, we would see that behind here, there's a big circuit board connected to this connector right here, and this circuit board is our network interface card. So this connector here is just part of the network interface card. For example, here is a full network interface card that goes into a personal computer. This part of it you wouldn't see. This is what you would see on the outside. Here is another type of jack. So when you're talking about Ethernet, which like I said is the most common form of rules or protocol that's used on networks today, the Ethernet specification, which if you actually open it up is like 100 pages long, if you were to read through all those rules, one of those rules would talk about what this jack is supposed to look like, how big it is, and this jack is called an RJ45 jack. RJ stands for Registered Jack 45. There's actually a specification out there that says an RJ45 jack is so big, it has so many metal connectors inside of it. An RJ45 is the type of jack commonly used by Ethernet cables. And here's an example of what an Ethernet cable looks like. And so this end right here would plug into our RJ45 jack. So many times you can't see the network interface card in its entirety. All you might be able to see is the port or the jack on the end that you plug your cable into. But behind that port or jack is where the circuitry and the rest of that network interface card exists. But, Ethernet is not the only set of rules out there for connecting to networks. For connecting to local area networks, Ethernet's pretty much the winner. Almost every local area network in existence today uses the rules imposed by the Ethernet protocol. But when you connect to a wide area network, like when you're connecting to Time Warner Cable or Sprint or Charter Communications or something like that, you're probably not using Ethernet. You're probably using some other set of rules. And so the cable and the jack will look differently. For example, another type of cable is called a coaxial cable. And you can see right here, coaxial cable is much thicker than Ethernet. It's not as bendable. It's not as easy to string around corners and stuff. The ends of it, that's not RJ45. That's a completely different type of connector right there. And here is the NIC card that connects to this coaxial cable. Once again, most of the NIC card we can't see. It's inside this box right here, but we do see the connector to it. And as far as Wi-Fi is concerned, you have to have a Wi-Fi NIC. If you're going to get on the Wi-Fi network and communicate wirelessly, you have to have a Wi-Fi NIC. Chances are you don't even see it. Like I said, some of the earlier Wi-Fi NICs, you actually saw the antenna sticking out. You don't see that so much these days. Most of the time these days in your laptops and your PCs and your tablet, the antenna is hidden. It's actually sort of inside, like right here. This is an old Nexus 7 tablet that we see right here. And the Wi-Fi antenna, you'd actually have to open it up, and it's inside the component itself. It's inside the guts of the tablet. And just to talk a little bit more about a Wi-Fi NIC, I can compare it to something that you do know. Think about the radio that you have in your car, okay? So the radio that you have in your car, typically what we call that is a receiver. Why do we call it a receiver? Well, that's because right now there are thousands of radio waves traveling all throughout your body, all throughout the air, going through your bones, through your blood, right? And some of those radio waves are radio stations with like music and talk radio and stuff like that. So the radio in your car, we call it a receiver because it has the ability to tune into one particular radio station, ignoring all the other ones. It's still getting all those radio stations all at the same time, but it has the ability to filter all those out and only send through the speakers the radio station that you specifically tuned into. Now we call that a receiver because it's receiving the radio frequency through the air, translating that into electrical energy, which then vibrates the speakers so that you can hear something. But it is not a transmitter, right? I can't talk into my radio, hey, WKC5, I love your music. They're not going to hear me, right? Because the radio in my car doesn't transmit out, it just receives in. Well, when you're talking about a Wi-Fi NIC card, you have inside that NIC card something that's similar to that, but in the Wi-Fi NIC card, we call it a transceiver. Transceiver stands for transmitter and receiver. So in your tablet right here, in your iPad or whatever, there's some antennas somewhere here, you know, usually along the side. There's one or two antennas. You can't see them, but they're built into this thing. And the Wi-Fi NIC card inside this thing is a transceiver. Just like the radio in your car, it has the ability to listen to Wi-Fi signals coming in. But unlike the radio in your car, it also has a transmitter. It has the ability to transmit out Wi-Fi signals. So we call that a transceiver. So Wi-Fi NIC card by another name is a Wi-Fi transceiver. So those are just some examples of network interface cards. A device has to have a network interface card, otherwise it has no physical way of connecting to whatever the network is that's in use right around you. So now let's talk about some of the components that make up your network infrastructure. Now, if you remember, what does that term infrastructure mean? That means other than the cables, the things that connect to the cables that give you access to the network. So one very common network infrastructure device is called a switch. So if we're talking about Ethernet, if we're talking about wired Ethernet, then with wired Ethernet, we have this idea that you have, let's just say, a couple of PCs here, or laptops or whatever, maybe a server. They have a NIC card with a cable coming out. Like I said, back in the old days, that would be one cable. They would all be tapped into one physical cable. But some people said, hey, you know what, that's not very efficient. Let's instead give them all their own unique independent cables, which all terminate in one box called a switch. So on the switch has multiple NIC cards. For example, there's a NIC card right there that cable is connecting to. There's another Ethernet NIC cable right there, another Ethernet NIC card right there. So like for example, on these smaller end switches here, you can get a switch with as few as like 2 ports or 4 ports. Here we have an 8-port switch, and each one of these interfaces has an Ethernet network interface card built into it. Or if you're talking about a really large company, you could have a monstrous switch that has literally hundreds of interfaces in it. Each one of these little interfaces here would go out to a separate device, like a server or a laptop or something like that. So that's what you see in most networks today. If you have an Ethernet cable plugged into a PC or a server or a laptop, the other end of that Ethernet cable typically will connect to a network switch. Now, the network switch, let's say I had something like this. So this is payroll up here. And then down here I had some other PCs or laptops, and this is marketing. And then lastly, I got some other ones over here. and this is human resources. Okay, and I have them all connected to their own switch. So here's a switch right here that they're connected to. Here's another switch right here that this department is connected to. And another switch right here that this department is connected to. Now, I could connect all three switches together if they were close enough, right? If they were fit, because if we're talking Ethernet here, like I said, Ethernet is a protocol. A protocol means it's got a set of rules. Well, one of the things about Ethernet, one of the rules Ethernet says is devices can only be so far apart. Okay, now, once you start studying networking, you learn what that distance is. But because Ethernet was developed for local area networks, it assumes that the farthest the two devices are apart is not very far, that they're still pretty close. So if all these devices were fairly close to each other, like on the same floor or something like that, yeah, I could connect them via switches like this. But if they're a little further apart, that's not going to work. Or here's another downside. When you connect everything with switches like this, you lose some of your security. In other words, if you're the type of person that says, well, I want to have a lot of control over what devices in payroll can talk to certain devices in marketing, and what devices in human resources can talk to devices in payroll. I want to control the security of my network like that. With switches, you've got some limited ways of doing that. But if you really want that kind of control, you probably want to implement a different type of a networking device called a router. So instead of having the switches interconnected together, instead we're going to connect each switch to a different kind of a networking device, which is called a router. So that switch will be connected there, there, and there. All right. Now remember, this router in this case has 3 network interface cards because he's connecting to 3 physical cables. But one of the things that makes a router unique from a switch, and if I actually showed you a router and a switch, and I will show you a picture of one just in just a second, at first you probably wouldn't be able to tell the difference. Physically, they look very similar to each other. But what they do under the hood, their capabilities, their features, are very different from each other. So one thing a router gives you, it gives you a lot more control over the traffic going through it. It gives you a lot more security about what traffic goes through, what traffic doesn't. Another thing a router can do that switches don't do is when you're talking about wide area networks, like let's say this here represents the internet. Okay, and this over here represents some company. We'll just say company A. They're connected to the internet. And over here is company B. They're connected to the internet. Now they're connected via routers. Now in the internet, there are millions of routers all interconnected together. So just imagine that all these circles represent routers. And then you can see via the way I've drawn it here that for company A's data to get to company B, there are multiple paths. These routers are all interconnected, and so there's many different ways that company A's data could get to company B. One of the things that routers can do is they have the intelligence or the smarts to determine, hey, I have multiple paths to send this data. Which path is the best path? That's one thing that routers do. When you have a large network of multiple routers connected, this is what we call routing. Routing is the ability to determine if I have more than one way to get somewhere, what way is the best. So that's another very common networking component is routers. Also, as I mentioned that there are multiple different kinds of network interface cards. I showed you 3. I showed you a network interface card that connects to a wired Ethernet segment with an RJ45 jack like the one built into your laptop. I showed you a network interface card that connects to like a coaxial cable connecting to your cable modem. And I showed you a network interface card for Wi-Fi, but there are dozens of other ones as well. Well, what if I had all these different kinds of networks. Wi-Fi network here, coaxial network here, Ethernet network here, something using laser light here, something using something else, and I need to connect them all together. Switches won't let you do that. Typically, when you buy a network switch, all the interfaces on that switch run one protocol. They have one certain kind of jack. This is another benefit of routers. Routers, when you purchase them, you can connect different kinds of networks together. I could connect a Wi-Fi network into a wired network using a router. I could connect a coaxial cable network into a laser light network using a router. So that's another benefit of a router. And then another very common component in networks today is your Wi-Fi access point. So here is your laptop, and these days you don't see any antenna or anything in that laptop, but it does have one. Let's just say that this line right here represents the internal antenna. Okay? So, now once again, like I said, it is possible to have the Wi-Fi NIC card of your laptop communicate directly with the Wi-Fi NIC card of John or Sally's laptop sitting right next to you in the cube next door, or just sitting, maybe 10 feet down at the other end of the room. But most likely, you're not doing that. So usually in Wi-Fi networks, you have all of your clients, which are your tablets, your smartphones, your laptops, all with their own built-in Wi-Fi NIC cards, all transmitting and receiving wirelessly from one central device, which is this, a Wi-Fi access point. So all of your laptops and PCs will be communicating with this central device right here. And then the Wi-Fi access point will have a cable on the back end. Usually you don't see that cable because it's like in the wall or in the ceiling. So the access point via its antennas terminates the wireless connection and converts that on the back end to a wired connection. And this is usually Ethernet right here, an Ethernet cable. So that's what a Wi-Fi access point is. It's a point that collects all the Wi-Fi signals from all the individual laptops and converts them into wired signals on the back end to send it to the switches and routers. So with that, that ends that section. So let me go back to the YouTube stream here and see if there are any unanswered questions I haven't gotten to yet. Depeche asked the question, do I have any sessions on network forensics? I don't personally. I&E might, but I don't personally have that. All right, hold on just a second here. My site is spinning around, which makes me wonder if I'm getting out to you guys. Okay, I guess it was just my laptop. I refreshed it and everything came up. Okay, so I don't personally have anything on network forensics. But if you want to see, and I'll show this to you. Once again, you don't need to pay anything to see this. If you want to see the various videos and courses that I&E does have, once again, you can just go to, let me expand this a little bit, go to streaming.ine.com. All right, so right there, you can go to streaming.ine.com, and from here, you can see everything that we have. So if you're interested in network forensics, if you're not sure which of these categories that might fall into, one thing you could just try is doing a search. Let's search on the word forensics. And yeah, it looks like in the right here, we have under the CISSP technology, there's a video in there under forensics. Under the CCNA cyber ops technology, there's something on forensics. So by starting with this page, you can see what types of courses and videos we have. And hopefully what you're looking for is in there. All right, what other questions do we have? Kawat asks a good question. What is the most difficult part about being a network engineer? That is a very subjective question. It depends on who you talk to. Some people, the difficult part would be that every once in a while they get a call at like 3 or 4 o'clock in the morning and they have to troubleshoot a networking problem, right? That might be the most difficult thing. Other people, it might be the stress of having people calling and doing a troubleshooting ticket with someone breathing down your back trying to fix something. Other people, it might be that, network technology is always evolving. It never stays the same. So for some people, it might be, man, I can never keep up. There's always something new coming out. And what's most difficult for me is just keeping abreast of the latest stuff. The latest stuff that's coming out is so rapid. So it really depends on who you talk to and what their job role is. And Bort 112, you say, how about layer 3 switches? So just to do a quick sort of tutorial on that. So here is my laptop, and it's connected to a cable. And we know that every time you type something on your keyboard, it converts what you typed into electrical energy, right? Like when I type a 1, there's certain electrical energy that's created for that. When I type the letter E, that's electrical energy for that. Well, the way your laptop or PC works is all that electrical energy is stored in memory as 1s and 0s. So for example, when I type the letter F on my keyboard, the electrical energy might look like this. Electrical energy goes up, holds it for a while, goes down, holds it for a while, goes up, holds it for a while, goes down, 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 and then down. So that might be translated to, okay, whenever the electrical energy is at this level right here, that's considered as a 1. So there's a 1, there's a 1. Whenever the electrical energy is at this lower level, that's considered as a 0. So 0, 0, 0. So when I press the letter F on my keyboard, that was stored in memory as 10100. I'm just giving an example right here. Okay? So when you transmit something onto the network, what you're transmitting is a bunch of 1s and 0s. Thousands or millions of 1s and 0s. Okay, remember how I said that there's different rules about accessing a network? And some of those rules are like, okay, when I put my 1s and 0s on the wire, if this is going to just Sally, how do I make sure that Sally knows it's for her? Well, if we're talking about human language, I just shout it out. Sally, this is for you. Well, when we're talking about 1s and 0s, some of these 1s and 0s have to indicate my address or my destination. Okay. So in the world of networking, there are two sort of basic kinds of addresses. Your NIC card, your Ethernet NIC card, right here. So here's my NIC. That has an address. Maybe this is my address right here in binary. That's my address. So anybody who's on the same wire as me, who wants to send information to my NIC card, at the very beginning of their stream of 1s and 0s, they have to put this. That way my NIC card will know, oh, that's for me. So that's considered you'll hear this term, layer 2 address. So whenever you're transmitting data onto the wire, you have to put the layer 2 address of the device on that wire that you're sending your information to. Now imagine this for a moment. You and dozens of other laptops are all connected to the same wire, and there's a router on that wire as well. Chances are 99.99% of the time, when you're putting your bits onto the wire, those bits are not actually destined for any of the other laptops on that wire. Those bits are destined towards Google, which is thousands of miles away, or INE, which is thousands of miles away. So in reality, those bits have to go to the router, because the router has to know, oh, how do I get this information to Google, to INE? So as your bits are going on the wire, the layer 2 address, the destination address, is the NIC card of the router. Okay, so remember, the router has a NIC card because he's connected to the wire too. So his NIC card has a layer 2 address, just like my NIC card has a layer 2 address. Okay, now, so that's the first address, that's the layer 2 address. I'll say layer 2 address. But there are other bits back here. For example, if someone on the internet, so let's say here's someone in Egypt, and their laptop is trying to send some information to my laptop. Well, when they put their ones and zeros on their wire, whatever wire they're connected to, the layer 2 address that they send to is not going to be my NIC card, because we're not on the same wire. They can't reach my layer 2 address. So the layer 2 address they're sending to is their router. So this is their router they're connected to. Hey router, I need you to pick this up and send it. But deeper on in here is another address, which is actually me. So your laptop, your tablet, your smartphone actually has 2 addresses. It has the address that's on the NIC card. So if people on your wire need to talk to you, that's the address they send it to. And there's another address in your CPU called a layer 3 address. Most of the time we refer to that as an IP address. So devices that are not on your cable that want to talk to you have to send their information to your layer 3 address. Now, what does this have to do with switches? When switches originally came out, here's a layer 2 switch connected to several cables, several wires. Okay, so let's say that here's some ones and zeros coming in right now, coming in this way. And let's say this is coming from Bob's laptop, and the destination is this router over here. Okay, so these bits right here refer to the layer 2 address, most likely of this NIC card right here. So I'll just say that's 111000, so we'll match it up. Well, one of the benefits of putting a switch in here is that when these bits came in, the switch had the intelligence to look at the bits and determine, oh, I need to forward them out this cable right here. Well, how did it do that? A layer 2 switch was able to look at these bits and say, oh, that is a layer 2 address. I have a table that knows exactly where that layer 2 address is. That layer 2 address was learned on port number, let's say 5. So as it comes in, the layer 2 switch can say, I can look at these bits, I can interpret them, and I know exactly where they go. A layer 3 switch, what we typically call a multi-layer switch. So layer 3 switch and a multi-layer switch are exactly the same thing. Has the ability, when data comes in, when asking itself, where does this go, not only has the ability to look at the layer 2 destination, it can look further in here, and maybe these bits are the layer 3 destination or the IP destination. So a layer 3 switch or multi-layer switch can look at both addresses to determine where something needs to go. So hopefully that wasn't more detailed than you cared to know, but that answers that question. So Prashanth, you asked, do I give training on physical labs? In other words, hands-on labs for candidates. I'm not sure what you mean by candidate. I'm going to interpret that as a candidate for a Cisco certification exam. So if you decide to go into the world of networking, if this is something that interests you, then most likely you'll want to start by studying for Cisco's CCNA certification exam. Let's mark that right up here, CCNA. And that stands for Cisco Certified Networking Associate. So Cisco has multiple certifications you can get. The CCNA is sort of like the entry-level certification, the first one, and then you can go up and they get progressively harder after that. So the CCNA is usually where people start, and I do have some video series that specialize in that. So for example, right here, if you go to streaming.ine.com and you click on Cisco and you click on CCNA, and you're going to want to start with routing and switching. You will see that in here there are several video series on that. For example, if you look at this one right here or this one right here, probably where you would want to start is this one right here. I'll zoom in on that a little bit. The ICND1 technologies. And in there, in addition to teaching you the technology about how things work in theory, we also talk about how do you make this work in a lab? What are the commands that you use? And I teach you how to do that. So hopefully that answers your question about lab training. Okay, and 133 major. I think you asked this question yesterday about contiguous versus discontiguous networks. Let me just quickly address that, and then we're going to take a break, because at that point it will be about an hour and a half since we started, and we'll take a quick 10-minute break. So, the difference between like discontiguous networks and things like that, what is that referring to? Well, so imagine that you have, let's just say that I'm going to draw a box here, which is going to represent a laptop or a server. Okay, so that's what a box is going to represent. Okay, and then those are connected to a switch. And then down here we have some other ones. Those are connected to a switch. Some other ones over here. And a few more. Okay, and we decide to connect our switches to routers. And we connect our routers together. Okay, so we know that these red boxes right here, up here, technically the only address they really need is the address on their NIC card, which we said was their layer 2 address. If all they want to do is talk to each other, if our goal was to have these 3 red boxes, these 3 laptops and servers talk to each other, all they need is their layer 2 NIC card addresses and they could talk to each other. But that's not realistic, right? In reality, we're going to want these red boxes here to be able to communicate with the purple boxes and the blue boxes. So we also need layer 3 addresses. We need IP addresses. Well, in the world of IP, we have what's called classful networks. I'm not going to get too far into this because this is going down into the details of CCNA. But let's say we have, in our company, we have the 20 network. We purchased that. All right, and we also have the 30 network. We purchased that as well. If I was to do contiguous networking addressing, that would mean, okay, maybe everybody up here is 20.1. something. That's their addresses. And everybody down here is 20.2. something. Everybody here is 20.3. something. And now I decide to go over to my 30s. This will be 30.1. something. And this will be 30.2. something. So can you see how going left to right, everything here on the left is 20 dot something, and then I have like a boundary. Let's just draw a little dashed line here. And everything to the right of that line now leaves the 20s behind, and now we're going into a completely different networking space, 30 network. This is what's called contiguous networking, where all the subcomponents or the subnets of the 20 network are on one section of my building or one section of my network, and when I move into another completely different network, now that's on the other side of my line. That's contiguous networking. Discontiguous networking is where it doesn't look like that. Discontiguous networking would be something like this. Or maybe I have the 30.2 over here, and I have the 20.2 over here. Now, of my 20 network, I have some subcomponents of it on the left. I've got another component of it on the right. The 30 network, same thing. I've got it sort of spread out. There's no logical way I've put these in place. I've just thrown a 20 over here, threw a 30 over here, threw another 20 over here. There's no logic or rationale as far as how I divide up these networks. So this is called discontiguous networking. That's all I'm going to refer to here for this. Anything deeper than that is more appropriate for a CCNA level video. It's not really an introduction to networking video. All right, so with that, let's go ahead. Like I said, it's been about an hour and a half here of continuous stuff. Let's take a break for about 10 minutes, and then I'll see you guys back in 10 minutes. Okay, and we are back. So let's go ahead and continue with where we left off. Shreth, I see you have a question there about clearing your concepts in subnetting. Subnetting is a huge concept. That's something that would literally take me 2 to 3 hours to cover, and unfortunately we just don't have time in this Intro to Networking Technologies course to go over that. So that's above the scope of this class. I would definitely recommend that you watch some of my videos. I have a whole video series on IP addressing and subnetting if that's something that interests you. Okay, so let's say that at this point in time you've seen enough about networking and you say, you know what, that's something I might want to do. What type of jobs can somebody do that implements this network technology? What's available out there? So I'd like to talk a little bit about that next. All right, so to begin with, before I go over the specific names or categories of the job roles, all these job roles I'm about to talk about have some common things that you do across all of them. Network analysis, design, implementation, troubleshooting, and monitoring. And computer networking roles will require you to perform one or more of these duties. So let me just go through each one of these in no particular order. So network analysis is the idea where you are placed in front of an existing current network and you are given tools for you to analyze the network from the perspective of, is this network doing what it was designed to do? In other words, we have to think about, why was this network created in the first place? What were the objectives behind this network? Why was this particular router chosen and put right here in this particular spot? Why was this particular switch put right here? Why were these particular cables selected? So we have to know in advance, what was this network's goal? What was its objective? And now we look at the network and we ask ourselves, is it meeting the objective? Is it meeting the goal as efficiently and effective as possible? Or do we need to change or tweak this network in some way to make it more effectively meet that goal, that objective? So that's what we call network analysis. Now let me jump down to the last one, which is network monitoring. Network analysis and network monitoring are very closely related, but network monitoring is more along the lines of, I'm looking at an existing network and I'm trying to determine if there's any problems. Are there any current problems in the network? Or does it look like the network is headed down a path where there's going to be a problem in the future? For example, with network monitoring, that would mean looking, for example, at a router and saying, here's the memory of this router, and pretty much all the time, the memory of this router is at 90%. All the memory is almost fully utilized all the time. So I see a problem that's going to be happening pretty soon down the horizon. I need to be aware of that and maybe do something about it. So network monitoring, you're not really concerned about what's the objective of the network. Why was this network built, and is this network meeting its objectives? That's network analysis. Network monitoring is, I'm trying to spot problems in the network before they happen. Or when problems do happen, I want to immediately be made aware of them and where they occurred. That's network monitoring. Network design is, like it says, designing a network from scratch. So first of all, determining what is our objective. You know, if I'm building a network in a brand new building, okay? Brand new buildings going up and the construction's happening. While it's being built, while the concrete is being laid, while the plumbing is being put in advance of all that, I'm thinking to myself, okay, how many people are going to be in this building? How many devices are going to be in this building? How are they going to need to communicate? Is that going to grow in the future? I want to design a network on paper that's going to meet the needs of the company that's going to go in that building. That is network design. Network implementation is taking someone's design. Okay, now I've got a document that says, okay, this network is going to need 50 routers and 40 switches, and here's how they're going to need to be connected together. And here's the various protocols and features that are going to need to be run to meet the objective. Well, network implementation is actually making that a reality. Going out and purchasing the routers and switches, installing them, cabling them up, going into the software of the routers and switches and turning on these features, making sure they're configured to operate as they're supposed to be operating. That's network implementation. And the network troubleshooting, that's probably pretty simple. That means, hey, there's a problem. You need to identify where the problem is, what caused the problem, and you need to fix the problem. That's network troubleshooting. So let's go into the various job roles now that would do one or more of these various things. So the four categories I'm going to talk about, or the four job roles, are the network architect, the network engineer, the network administrator, and the technical support or help desk. So let's start by looking at network architects and network engineers. A lot of times these terms can be interchangeable. So if you're applying for a job that's being advertised as a network engineer or a network architect, you'll want to make sure that you're very clear on what the job roles are and what they're expecting of you in this role. So network architects and network engineers, some common things they both share. They're generally hired to work on larger networks. Okay? Networks that have dozens or hundreds of routers and switchers and network components, really big. They generally do network design and conception. Okay, so both network architects and engineers can do that. Prototype testing. That's more the realm of a network engineer. So a network architect, as it says here, is really more for the design aspect. So the network architect is the one who will think up the network from scratch, who will design a document in paper or on the computer about what the network should look like, how many devices should be in there, how they should be interconnected, what protocols and features, and then they'll leave. The network architect's job is generally done at that point, and the network engineer will then implement that concept that the network architect came up with. So the network engineer will typically do the prototype testing. An architect might do that as well. And network architects are typically hired as consultants rather than W-2 employees. So if what you're looking for is a job with a lot of stability, a lot of security, a job that you know that you'll get a constant paycheck, you'll get benefits like health benefits, vacation or paid time off, and hopefully you'll be able to do that job day after day after day, year after year after year, that would be more of that network engineer. A network architect is someone who will come in for and work on a contract for like 6 months or 9 months or maybe a year, and then their job will be over. Now you might be wondering, well, then why would I ever want to do a network architect versus a network engineer? Well, a couple reasons. If design is what really interests you, you say, hey, look, I'm not really interested in troubleshooting networks. I'm not really interested in screwing routers and switches into racks and plugging in cables. I want to design networks. I want to conceptually think up. I want to be presented with objectives and come up with a network that meets that objective. And I want to get paid a lot of money. Well, that's the network architect role. Of all these roles I'm going to show you here, the network architect gets paid the most money. But of course, that means you have to have the most experience. You're not going to start out as a network architect. A network architect is like your end goal, something you hope to achieve after working in networking for 10 plus years of experience. So given this topology right here, you know, if you were, I'm going to zoom in on this a little bit, if you were a network architect, what value would you bring to this? Well, as a network architect, you would think this thing up from scratch. You would know, you would have devised this topology because you would know what objectives the company needed. The company would have told you, hey, we're going to have so many people in payroll, so many people in human resources, and these are the applications we're going to run, and we need the network to support this, this, and this, and needs to support this in this time frame. Well, the network architect would devise all of this, would conceptually build this from his or her imagination. Okay, so that's what the network architect would do. Now, if we're talking about a network engineer with the same topology, the network engineer would do like proof of concept testing, right? So the network architect may have said, hey, you need to put 200 routers and 500 switches into this building, and they need to run these very complex features and these very complex protocols. Well, the network engineer would say, okay, before I go out and buy those 200 routers and those 500 switches, why don't I build a smaller scale of this and test it out and make sure it works the way the designer, the architect, said it's going to work? Why don't I go out and buy maybe 10 routers and 20 switches, connect them all together, make sure I know how to turn on these features and protocols that the architect said I need to run, and make sure these features and protocols do what they're supposed to do. In other words, build a prototype, and then if it all works, then build it out to a much larger scale. That's what the network engineer would do. Now, if you're just getting into the networking field, a network engineer, a network architect, like I said, that's not going to be your first job. Okay? Your first job may be this, the network administrator. So, as a network administrator, so if you say to yourself, hey, you know what, and I was telling somebody just earlier today this idea here. I said, okay, somebody said, hey, I know someone who wants to get into the field of IT, information technology. And they said, is Cisco the place to start? And I said, well, it depends. I said, if you're getting into the world of IT, and this is the way I described it to her, I said, the world of IT can be sort of broken down into three sort of high-level categories. I said, there are the server folks. Okay? So in the world of IT, you have your server people. These are the people who know Microsoft and Linux and Unix really, really well. These are the people who know how to set up servers to do email and web browsing and file serving and stuff like that. So that is a section of IT. If that is somebody's interest, they don't really need to know Cisco for that. They need to know Microsoft really well, most likely. And then I said the second portion of IT is programming. Okay? Maybe you want to write the code that does all this stuff. You want to write the code that comes up with a new email program. You want to write the code that hosts a website. Okay, once again, Cisco, it's probably not the direction you want to go in. If you want to write code and do programming, you probably want to go into the direction of, Java or PHP or Python or something like that. And then the third part of IT, yeah, that's networking. And if networking is your thing, then yes, you probably want to start out learning about Cisco technologies. Okay, so if you want to go in the world of IT, first you have to decide which one of these sort of three areas, the area of server, the area of programming, or the area of networking that you want to get into. Well, what does that have to do with a network admin? Well, chances are unlikely, not very likely, that your first job in the world of networking is going to give you the luxury of just working in this field right here. Highly unlikely that your very first job will get you just on routers and switches and you'll be able to ignore that and that. Unlikely. Most networking administrators, as this slide says right here, have to deal with not only the network infrastructure, they have to start learning about routers and switches and how they work, but chances are pretty good they'll have to know something about servers as well. Most network administrators start out having to have a blend of both. And that's what this is referring to. Now, the network administrator will also be in charge of installing and configuring new equipment. And here I'm really referring to networking equipment. Okay, so when the network engineer purchases those 200 routers and those 500 switches and all the miles and miles of cables that go along with that, the network administrator is the one who's going to lug those boxes to the various parts of the building, unpack them, screw them into the various networking racks, plug in the power supplies, plug in the cables, and get everything physically in place to where it needs to go. And then the network administrator is going to do some of the basic configuration. So some of the real basics of adding addresses to things, configuring the basic routing protocols and stuff like that. The network administrator will do that. And of course, cabling and implementing change requests and implementing upgrades. Okay, so if 6 months down the line, the network engineer decides that this particular brand of router we have is no longer working, it's no longer doing the job. Well, they'll order the upgraded router or maybe an upgrade module, maybe upgrade memory, and the network administrator will be the one to implement that, to implement those change requests. Or a very common way for people to start out in the world of networking is as a technical support engineer. Now, a technical support engineer typically doesn't have any hands-on installation of equipment. Okay? All the stuff they do is sort of behind the scenes. They'll do phone support of trouble tickets, sort of decoding what the problem was with the router switch or the network infrastructure device without actually being right there physically in front of it. Now, one thing I will say about a technical support engineer, like this last bullet point says here, it builds great foundational knowledge of the software and the network operating systems. So you might not learn the real distinct differences between different types of cables, different types of network jacks and interface cards, and how to plug things into a power supply. But what you will learn as technical support is all the details of how the software works. Once you log into the router or the switch, you will get very well versed on the commands and how to configure that thing to do what you need it to do. So for all these things, you might be wondering, okay, well, is this the right fit for me? Do I have the right temperament, the right personality to go for these jobs? So who is right for the job? Well, if all of this applies to you, you're right for the job. You must be highly organized. You must enjoy learning new things. Network technology is always changing. It's always coming up with new things, and so you have to enjoy that. You got to be willing to work off hours. Pretty much all these jobs, with the exception of the network architect, but from the help desk all the way up to the network engineer, there are going to be times when things go wrong and you have to troubleshoot problems at midnight or 2 a.m. in the morning. There's going to be times when part of the network has to change because you're swapping one router out and you're putting a new router in place, or you're upgrading the network to some newer software, and you can't do that during working hours because that would interrupt the network. You got to do that off hours. You should be a critical thinker, right? You need to be able to take problems as they come into you and distill them down to the root cause of what that problem is. And you should be able to work well with others. Right? You're going to have to be able to working hand in hand with other people. People are coming to you with their problems. People are coming to you looking for ideas as far as ways to make the network better. And you need to be able to communicate yourself well. You need to be able to have a calm disposition. And you need to be able to sit in front of a computer monitor for extended periods of time. This is not a job where you're going to be on your feet, walking around, getting a lot of exercise out in the fresh air, right? So this is not going to be that. So if all of that describes you, if you say, yeah, I'd be happy doing that, and I think I am those things, then yeah, you can pursue a job in the computer networking field. Now, like I said, chances are the first networking job you're going to be looking for is as a network administrator. And you might be wondering, how much does that pay? I can only speak for the United States. Okay, so these numbers I've collected here are based on various websites that talk about the US. So you can see PayScale, Glassdoor, SalaryOne.com, and these give you some ideas as to average rates for network administrators. And you can see it ranges fairly widely. But looks like I'd say the average pay for a network admin would be around the $50,000 range as a starting salary here in the United States. All right, so let me go to the Q&A and see if there are any outstanding questions that I can help you with. Shreth, I'm not sure what type of EIGRP questions you would possibly be asked in an interview. If someone's going to ask you questions about EIGRP, a lot of that depends on what level of a job you're seeking. I mean, certainly if you're seeking as a job as a network administrator, the questions they're going to ask you regarding EIGRP are going to be of a lower level of complexity than if you were seeking a job as a network engineer. I would definitely walk into that interview knowing how EIGRP forms neighbor relationships and what are the things that could prevent a neighbor relationship from forming. How EIGRP sends routing updates from one router to the other, and what you need to configure on a router to get it to advertise EIGRP routes to another. At basic, I would definitely advise you to know those things. At the CCNP level, you would need to know redistribution. If a router has learned about routes from other routing protocols like OSPF or RIP, how do you get those into EIGRP? And what are some of the things that could go wrong when redistributing routing protocols into EIGRP? And also EIGRP filtering and summarization. You would want to know that stuff. And Mr. Fail Standstill, good name. Question about MTU sizes. So there are those two different values you're putting there, 65, 536, and 1500, are relating to layer 3 versus layer 2 MTU. The main MTU that you really want to be concerned with is your layer 2 MTU. And what I mean by that is the internet protocol might think to itself, oh, when I'm collecting ones and zeros and I'm formatting them into a structure called a packet, that packet can be 65,000 bytes long, which is really big. But that doesn't do you any good if your layer 2 protocol, which is Ethernet, says, hey, when I start putting bits on the wire, I have to stop at 1500. After 1500 bits, my time is done. I now have to give the wire up so somebody else can talk. So the layer 2 MTU, if you're comparing layer 3 and layer 2, I would say layer 2 MTU, which is typically 1500, is more important because that's the maximum quantity of bytes you can put on the wire before your NIC card says, I'm done, I can't talk anymore. I have to give somebody else a chance now. And Tiang, is it useful now to study Python and Python networking? Python is definitely useful as a language, but I would say if you say, well, I need to learn basic networking like Cisco CCNA stuff, and I also want to learn Python, I would say start with the CCNA stuff. If you're going to be interviewing for jobs as a network administrator or even as a help desk person, they're going to want to see that you know CCNA. If you go in there saying, well, I know Python, but I don't know CCNA, they're not going to hire you. They're going to say, well, Python doesn't have anything to do with networking. Just because you know Python, that doesn't mean you can configure my router. Doesn't mean you can configure my switch. You don't know how the software works. So you want to start out by learning the CCNA stuff, and probably even after that, learn your CCNP stuff. Then you can take a break and learn about Python. But I would start with the CCNA level technologies first. And every layer 2, so this 133 major, this is answering your question, every layer 2 technology, and remember, a layer 2 protocol is talking about how do I put bits on the wire? When can I talk? When do I need to stop talking? How do I address these bits so the other person on the wire knows it's for them? Ethernet is a protocol that answers those questions. Frame relay is another protocol that answers those questions in a different way. The point-to-point protocol is another protocol that answers those questions. Well, all of your layer 2 protocols, in the set of rules that they operate by, one of the rules is how many bits can I put on this wire when it's my turn before I have to stop, before I have to stop speaking and give somebody else a chance. That's called MTU, maximum transmission unit, is the rule that says how many bits I can put on maximum. So whatever protocol you select, you should know what the MTU is. That's just part of knowing how the protocol works, how it operates. And Kawat, you ask a good question. If you're preparing for the CCIE exam, would it be better to dedicate more time for studying the theory or labs? Which one? I would say that of all your study time, you probably want to devote 70% to theory and 30% to labs for the CCNA. You definitely got to know the iOS commands, but ultimately there's a lot of stuff you got to memorize, a lot of theory you have to memorize. Maybe not 70-30, maybe more like 60-40. 60% of your time should be theory, 40% should be studying the commands and practicing the commands in the labs. And I wouldn't necessarily say that routing and switching is losing its reputation value because of cloud. You will always need to know routing and switching. All that cloud means is that you're taking your servers, which used to exist in your company, in your data center, and now you're using somebody else's servers. You're using like Amazon servers, or you're using Google servers. But guess what? You still need routing and switching to connect your network to their network. If you don't know routing and switching, you can't build a network in your own company to connect to their network. And if you don't know routing and switching, you can't troubleshoot. Why can't I reach their network? So routing and switching is always going to be the foundational level principles behind cloud and everything else. And 133 major, there is no single book, there is no single set of videos you can watch and pass your CCNA. There's just too much to know. There's too many things that you have to understand. So, like I said, to prepare for and pass your CCNA, it's going to always be a combination of reading something, watching videos, and doing hands-on lab practice. You have to incorporate all of those things in order to pass any Cisco certification, including the CCNA. So the last thing I want to talk about, this next and last topic, is the topic of where do I go from here? So now you've reached the point where you say, okay, networking sounds interesting. I'd like to work in that job field. Now you sort of, at a high level, understand the differences between help desk, network administrator, network engineer, network architect. And I understand that based on the level of where I'm at right now, the job I'm probably immediately going to be looking to get within the next 6 months to a year is either technical support or a network administrator. All right, how do I get there? What do I do from here to get to there? All right, so here's what I'd recommend you do. Number one, you're going to want to start studying for your Cisco CCNA. And there's books out there. The books I would recommend for the Cisco CCNA, and I'm not going to spend too much time on this because I have another show called a CCNA Kickoff that you can look for this. But Cisco has, let's see here, where is it? So I go to Amazon.com. Let me make this a little bit larger. From Amazon, the two main books you're going to want to search for are Cisco ICND 1 in books. Okay, so see right here, this first one. It says the ICND 1 100-105 Official Certification Guide. That's the first book you're going to want to get. Either in soft copy or hardbound, you're going to want to get that book and start studying it. To get your CCNA, you're going to have to pass 2 exams. The ICND 1 exam, and this book will help you study what you need to know for that. And then after that, there's the ICND 2 exam. So you'll want to get the official certification guidebooks for ICND 1 and ICND 2 and just start pouring through that, making flashcards for yourself, and really memorizing and studying what's in those books. So that's step number 1, is preparing for your ICND 1 and your ICND 2 certification exams. While you're doing that, these are the other things you're going to want to do. Talk to someone. So you should identify someone who's already doing the job. A network administrator at your current job, or if you're going to school, your school has a network. Who supports that network? Find out who it is. Talk to somebody. And once you start talking to them, here's the types of questions you want to ask them. Ask them, what do they do? Hey, John, just, describe your day for me. What's your common day look like? What does it look like to you being a network admin? What kind of experience did you get before you got hired? Did you get a CCNA? Did you get something else? How did you learn what you know now? Also ask them, what kind of skills do you consider important? When you think about what you do on a day-to-day basis, what skills are important to be successful in your job? And you can say, hey, look, here's where I am right now. Right now I'm an auto mechanic. I'm studying for my CCNA. Is there anything else you would recommend that I do to get me from where I am now to get me to doing the type of thing that you're doing? Can you help me with developing a roadmap to eventually be a network admin like you are? Also, I'd recommend that you watch some YouTube videos. There's a lot of YouTube videos out there where people interview network engineers. For example, there's one guy called Eli the Computer Guy. You can search for him on YouTube. And he has a lot of videos where he interviews network architects, network designers, network administrators, and he asks them questions like this and others. And just by sitting back and watching those, you can gain a lot of experience as far as how did people get into that position. I would also recommend that you get your hands on just a few basic networking things. I'd recommend that you purchase 2 routers and a switch. Okay? This is your minimum home lab that you're going to want to create. I'd recommend that you get a couple of Cisco 3725 routers and a 3560 switch. They're probably even less than, this was taken over a year ago, these prices, so they're probably even less than that now. And the reason I'm recommending the 3725 routers, you might say, well, Keith, there's lots of Cisco routers out there. Why those? Well, because there's a free program you can download called GNS3. So you can go to GNS3.com. All right, GNS3.com. And from here, you can download their free software onto your laptop, and then GNS3 works with Cisco router software from the 3725 platform. So if you buy the 3725 router, which is going to have the 3725 software in it, you can save that software from the router into your laptop and now pair it up with GNS3. Now you might say, well, why would I ever use GNS3? I already have 2 routers and a switch. Why would I do that? With GNS3, you can build much larger topologies. If you start thinking, well, I'd like to build a topology that has like 6 routers and 4 switches in it. Now that you have the 3725 software because you bought the router, you can build those larger topologies with GNS3. So that's why I recommended that you have that particular model of router that you buy. And once you have the physical routers and switches in front of you, these are the types of things you can practice. You know, this is stuff that you can't do remotely. You know, there's some stuff you can do with simulators and emulators or by logging onto someone's remote racks. But these things right here, these 6 or 7 bullet points, you really can only do if you have physical equipment in front of you. And that's why I'm really recommending that you start out with a real primitive lab of just 2 routers and a switch that gives you the ability to do this. One last thing I want to talk about when we're talking about Cisco certifications. As I mentioned, Cisco certifications come in multiple levels. You have your entry-level certifications, and then they go up from there. So these map out to the CCENT. That's a Cisco Certified Entry-Level certification. This is the CCNA. Now the CCENT is the same as the not ICDN, the ICND1 certification. So if you just pass the ICND1 test, you now have your CCENT. If you pass the ICND1 and the ICND2, now you have your CCNA. So once you get your CCENT, you're halfway home to getting your CCNA. Then the professional level is the CCNP. Expert level is the CCIE, Internetworking Expert. And the architect is the CCAR. CCAR is virtually impossible. There are, I think, like 12 CCARs in the entire world. Good luck getting that one, and it is super, super expensive. So you might want to just shoot for the next, let's say, 3 to 4 years of eventually becoming CCIE certified. So within year number 1, you want CCNA to be your goal. By the time year number 2 is over, you want to have CCNP. And by the time year number 3 or year number 4 is over, you want to have CCIE as your goal. Now, all of these I've written out right here in brown, these ones here, are all geared towards teaching you how to implement, monitor, and troubleshoot networks. None of these certifications I've drawn out here really have much of anything to do with designing networks. Okay? So if network design is your interest, I would still say you should start out with CCNA. I would say start out with CCNA. You want to get your CCNA. Now that's, once again, that's for implementing and troubleshooting basic networks. At that point, any certifications that you see with a D in the name are for design. So there is the Cisco Certified Design Associate. But you don't want to go for your CCDA until you have your CCNA. All right, the CCDA pretty much assumes that you already have your CCNA behind you. And then they have CC Design Professional and CC Design Expert. So all these with a D in it are not about implementing and troubleshooting networks. They are all for designing networks. And that is all I have for our show today. So let me just go ahead and go back to the YouTube stream and just see if there are any residual questions I haven't answered yet that I could answer for you. So Mr. Fail Standstill says, is 27 years too late to enter the networking engineer path? Absolutely not. You could be 50 and enter the networking engineer path. I don't think it really matters what age you are. Certainly 27, not at all. I wouldn't even worry about it at 27 years old. Taeyang says, is it possible to take all 3 CCNP exams in one go? No, it's not. So let me think about this. Let's say that theoretically you had been working in networking for quite a while. And so Taeyang actually brings up a good point. So after you're done with your CCNA, to get your Cisco Certified Networking Professional certification, it's 3 tests, 3 separate tests. Now, let's say that in theory you had been working in the networking industry for quite a while and you actually knew everything you needed to know to pass those 3 tests. Well, theoretically, I mean, you can't take them all at once. But yeah, theoretically, I could schedule my first test for tomorrow, my second test for later on that afternoon, and then my third test for the next day. So you could sit and pass all 3 tests within like a 24-hour period, assuming that you already had all that knowledge. I have never heard of anyone doing that, but theoretically it's possible. Was the best tool for lab practicing? Shreth asks. If you are preparing for your CCNA exam, I would say the best tool is Cisco's Packet Tracer. And that's a free tool you can download. Just type in Google, just type in Cisco Packet Tracer. You'll have to register for their Network Academy, but that's just giving them your name, your email address, and coming up with a password, and then you get to download Packet Tracer. If you are studying for anything above CCNA, then Packet Tracer will not be appropriate. You'll probably want either GNS3 or maybe Cisco's Viral tool, the Virtual Internet Routing Lab for that. You can also log on to racks remotely. One of the things that we offer here at I&E are racks that you can rent time on, where you actually get time on real routers and switches. And if you're interested in that, what I would recommend that you do is, I think here on YouTube, if you just do a search on I&E rack rental, yeah, right here. How to use I&E's rack rental system for CCNA and CCNP preparation. So I've got 14 videos in this series, all free, all you can watch here, that go through all the details of what our racks are, how you schedule time on them, and how you work on them. So you might want to look at that as well. Okay, and last question here, Majid asks, why not the CCAR? Well, the CCAR is a great long-term goal, but like I said, number one, it's super expensive. It's like $15,000 to get your CCAR. They have a requirement that you have like 10 or 15 years of experience. It's just, you have to stand in front of a panel of people and present. It's like getting a doctoral thesis in networking. So very few people have their CCAR. It's great to have as a goal, as an objective, but I would say it's much more achievable to get a CCIE than to get a CCAR. So with that, I don't see any other questions that have come in, so I'm going to go ahead and close up shop at this point. So thank you everybody for tuning into our show today. I hope it gave you something you didn't already know. If you knew nothing about computer networking, hopefully you know a little bit more now, and maybe this has whet your appetite into pursuing this as a career or a field for your employment. And have a great weekend, everybody, and I hope this was useful to you. I'll see you again for our next show.